started our discussion about instructions with the move instruction, which belongs to the data transfer instructions group. The move is not only instruction which copies the data. While the P6 architecture was introduced, the conditional move instruction appeared. The conditional instructions used the current state of selected flags in the flag register to determine how the instruction should behave. Flags are set or cleared according to the results of arithmetic, logic, shift, or other specific instructions. A good example is the carry flag, which is set if the result exceeds the maximum possible value for the addition operation. After the addition, we can test the carry flag and decide on further actions in our program. And here we can use the conditional move instruction, which tests the state of the chosen flag and moves data if the condition is met, and doesn't move if the condition is not met. Condition appears as the suffix in the instruction mnemonic. There are 30 condition suffixes. You can find them all in our book and in the processor's documentation. We'll mention two of them as examples. We'll use the add and the test instruction, which we described in other videos. After adding two registers, RAX and RBX, the result can be higher than the maximum value possible to be stored in 64 bits. In such a situation, the carry flag is set, and the conditional move instruction loads 1 into RCX. If the result doesn't exceed the maximum value, the carry flag is cleared and RCX remains unchanged. The test instruction performs a bitwise AND on two operands. Test executed with the same register used twice sets the 0 flag if this register contains 0. If this is true, a conditional move instruction loads 1 into RCX. If the RAX register doesn't hold a 0 value, the 0 flag is cleared and RCX remains unchanged. Another interesting data transfer instructions are these which allow use to copy data from a smaller source to a larger destination. At first sight, it is nothing complicated, but let us consider a simple example of copying an 8-bit value from the BL register to a 16-bit AX accumulator. If the value copied is unsigned or positive, let it be, for example, 5, the remaining upper bit should be cleared. This situation changes if the value is negative. Let's change the +5 into -5. As we can see, we can just fill the AH with zeros. The proper results we can obtain by filling them with ones. The proper result in both situations can be obtained by copying the sign bit of all into all higher bit positions. This operation is named sign extension and can be performed with a set of instructions. Sign extension instructions do not have any arguments and work solely with the accumulator. The CBW instruction converts a byte in AL to a word in AX. The CWD instruction converts a word in AX to a double word in pair of registers DX and AX. CWDE converts word in AX to double word in EAX. CDQ converts double word in EAX to quad word in pair of registers EDX and EAX. CDQE converts double word in EAX to quad word in RAX. CQO converts quad word in RIX to double quad word in pair of registers RDX and RAX. There are also more universal instructions which are not limited to the operation on the accumulator and copy and extend data at the same time. MoveSX copies and sign extends a byte to a word or word to a double word. MoveZX copies and 0 extends a byte to a word or word to a double word. MoveSXD copies and extends a double word to a quad word in x64 processors. Note that in these instructions, unlike the ordinary move, the source operand has a different size than the destination operand. Please watch our other videos about instructions. For a detailed description of instruction groups and instructions, please refer to our Purple Book and AMD and Intel documentation.